All right, so Pythagorean theorem. What we have here, the Pythagorean theorem is used to find the missing side of a right triangle. Okay, this has to be a right triangle for you to use this, because if it's not, it's just not going to be able to work. This postulate only works when you have a right triangle. So sides A and B are called the legs of this right triangle. And then side C is called the hypotenuse. You may have heard this before. Hopefully you have seen this lesson before, and I've done it maybe in Math 1, but sometimes I understand it's at the end, and maybe you just didn't get to it, or your teacher didn't get to it, or something like that. Or, there's a virus and pandemic that, hits the earth, and everything changes. So, which is why I'm making these videos. So pretty much for any right triangle, we have this famous formula that everybody remembers. You could probably ask your parents and they would still be able to remember a squared plus b squared equals c squared. Now, how often they use it, we'll talk about that a little later on. But this is very important for geometry, for carpentry, there's tons of applications of this. This is one of the most foundational theorems and formulas that you can use to apply to all sorts of higher level math. So, first off, we will pretty much just make sure you understand that the right angle right here touches the two legs. And those two legs are going to be A and B, like we talked about before. So we'll have A, which is 8 squared, plus B, which is 13 squared. And that will equal C, which is always the hypotenuse, which is the longest side. And we're just going to call that X squared. You can call it C if you want to, but it's no big deal. So that will be 64 plus 169 equals x squared. When you add those together, that gives you 233 equals x squared. And the way to get rid of x squared is to square root it. So our final answer here will be, it says just to round it to the nearest tenth here, and I'm perfectly fine with that. That'll just be 15.3. Now, it's the same sort of thing when they ask you for a missing leg. So we see that we have x squared plus 7 squared equals 9 squared. Now they actually gave you the hypotenuse. Now there's two ways that you can do this, right? You could just do x squared plus 49 equals 81, and then just subtract 49 from 81, and that'll give you 32, square root both sides, 5.7. That's perfectly fine. But for some of you guys, I want you to understand that there's a shortcut, a faster way to do this, right? So if I give you, let's look back at number 1, for example. You see how this is just x squared? Well, our whole goal is to solve for x. So really what I could have done is square rooted both sides from the very beginning, and that will cancel out that squared, right? So in other words, the square root of 8 squared plus 13 squared will take you straight to 15.3 if you type that in. Same thing over here. This x squared, we're trying to get the x squared by itself. So what if I kept it as 7 squared right here, and I just subtracted that 7 squared to the other side? Isn't that exactly what we're about to do with the 49? So we would have x squared equals 9 squared minus 7 squared. There's the jets flying over my house, if you heard that. So then we would just square root, and we'd do the same thing. So that would be 9 squared minus 7 squared. So it kind of just all depends on what they give you. But if they give you a leg, like for number 4, I could go ahead and tell you, hey, it's going to be the square root of 30.5 squared minus 19.1 squared. And that will give you that missing leg. For number 2, I can go ahead and tell you, hey, they are missing the hypotenuse. So all I have to do is add the two legs together, 27 squared plus 22 squared. That might be more for an honors track, or for some of you guys in regular classes that are really getting the hang of math and really understand it well. But if not, just stick to the formula. A squared plus b squared equals c squared. Find those two numbers, subtract them. There's nothing wrong with that. It just gets you to the final answer in a different way. So for number 5, we do have a right angle here. That x is being dropped down. We have 24 from both of these. And then if that 22 is the whole thing, we know each of these is 11. So really, we're only dealing with one triangle here. And we have 24 as a hypotenuse. X and 11 are the sides. or are the legs. So then from there, we can just do the square root of 24 squared minus 11 squared. And for number 5, that'll give us 21.3. Again, you can do it the other way if you want to. I'm going to keep doing it this way because it's a little faster and it's more challenging. So what we're looking for here is x, and we need to make this a triangle, right? So right now it's not a triangle, but if I put this little line here, I know that that's the same value as x, right? And I know that this is also a right angle. So I'm just looking for a leg of this hypotenuse. Now, here's the thing. 18 is bigger than 16, right? Well, that's because 18 is this whole line right here. We're not talking about the whole line. We just want this portion of it. So we need to do 18 minus this 5, and that will give us 13 right here. So we have x squared plus 13 squared equals 16 squared. That will be the square root of 16 squared minus 13 squared, and your answer for that will be 9.3. Okay, so I'll continue to do a couple of the difficult ones with you. For number 7, we're looking for the whole thing of x right there. So we really need to find this first one, I'll call it x1, and the second one, I'll call it x2. So we have two different problems here. We'll do 14, or x squared plus 12 squared equals 14 squared. So that will be the 14 squared minus 12 squared, and the square root of it. That will give us x1, which should be 7.2. And then I'll do the second one over here. I'll do x2, and that will be the same concept. X squared plus 12 squared equals 29 squared, and we will subtract 29 squared minus 12 squared. And that one will be 26.4. So we just add those two together, and that equals 33.6. There is your final answer. All right, for number 8, 28 and x. We're looking for that one. So pretty much we have two triangles here, and if we find this side, then we can help find x. But right now we don't know what that side is. So I'm going to call that y. All right, so we need y squared plus 10 squared equals 25 squared. And that should be 22.9. And that will be 25 squared minus 10 squared and the square root of that quantity. So if that's 22.9, then we can just take x squared plus 22.9 squared equals 28 squared. So we'll do 28 squared and minus it, subtract it from 22.9, and that will give us 16.1. There's your final answer there. You can always use some common sense here. You know that 16.1 has to be smaller than 28, right? So 28 is your hypotenuse. So if you get a number that's bigger than 28, you know you probably did something wrong. All right, continuing on to the word problems. It's pretty much the same thing there for 9. To find this distance right here, to just subtract 40 from 26 and then half it, right? So that will be 7 each. Hopefully that'll help you guys out. For number 10, a roofer leaned a 16-foot ladder against a house. So there's his 16-foot ladder, right, against the house. And the base of the ladder is 5 feet away. This is obviously not drawn to scale, right? And here's a little house with a messed up roof. Yep, there you go. So how high up the house does the ladder reach? So we're asking for this quantity right here. X squared plus 5 squared equals 16 squared. And we will do 16 squared minus 5 squared, and I'll go ahead and mark off that squared and put a square root. So our final answer there would be 15.2, which again has to be smaller than the hypotenuse. So that makes sense. If we got 17 or something higher than 16, we know we would have done something wrong. All right, so Kurt is building a rectangular deck. The dimensions of the deck are 10 feet by 23 feet. So here's 10 feet, here's 23 feet. What is the length of the diagonal? That's a pretty easy problem right there. I'll let you guys handle that one. Ashley jogged 3.4 miles east and then 5.7 miles south. How far is she from her starting point? Again, pretty self-explanatory. And then for number 13, a 31-foot support wire is attached from the top of a 25-foot telephone pole. So here's your 25-foot telephone pole. Here's your 31-foot support wire. And it says how far from the pole's base does the wire meet the ground. So we're looking for this right here. X squared plus 25 squared equals 31 squared. And that will be the square root of 31 squared minus 25 squared.